Okay, picture this. We have just successfully built a 12-story artificial brain. It's got the absolute perfect architectural scaffolding to understand human language, to process complex logic, and to seemingly reason with us. It's honestly a marvel of modern engineering, this towering wireframe of limitless potential built entirely out of silicon and code. But right now, at this exact moment, it is completely, undeniably brain dead. It's just an empty vessel. Sure, it has the structure to hold intelligence, but it contains absolutely none.
If you were to walk up, turn the power on right now, and ask this incredible, towering machine to, say, write a simple poem or answer a basic question, it absolutely won't give you a brilliant answer. Actually, it won't even give you a coherent one. It's just going to spit out a continuous, random string of broken, chaotic garbage. And there's a really simple mechanical reason for this. You see, its 124 million internal knobs, what engineers call its parameters, are currently set to completely random numbers. And these numbers aren't just random, they are mathematically totally divorced from human reality. The raw, untrained machine knows absolutely zero about English or history or logic or how our world actually works.
So that brings us to the million-dollar question, right? How do we transform this completely empty vessel into actual functioning intelligence? Like, how does a hollow, lifeless tower of math actually learn to speak? Well, to turn this cold structure into a mind, we can't just program a dictionary into it. That doesn't work. Instead, we have to force it to play a brutal, relentless guessing game. It's a fascinating, deeply complex, and honestly, almost agonizing mathematical process. And once you truly understand how it works, I promise, it's going to fundamentally change how you look at every single piece of text an AI ever generates.
Welcome to the overview effect, where you zoom out and everything changes.
So to teach our empty tower, we have to enter what is probably the most agonizing and resource-intensive phase of this entire AI pipeline. We enter the furnace of pre-training. Pre-training is basically this brute force process of feeding the model billions of words, forcing it to predict the very next word, and then adjusting its internal weights every single time it makes a mistake. We take this massive data set, just a sprawling, almost unfathomable collection of digitized books, Wikipedia articles, scientific papers, and random internet forms. It is essentially reading the collective conscious output of humanity, completely unsupervised. We feed a tiny chunk of this text into the very bottom of our tower, and we send it upward through all these complex attention mechanisms and mathematical geometry.
Let's say we feed it a total classic. The quick brown fox jumps over the data flows upward through all those layers. But remember, because its 124 million knobs are still dialed to completely random, nonsensical numbers, its very first prediction is spectacularly wrong. It makes a totally blind guess and confidently spits out the word refrigerator. Now, what's truly fascinating here is how the system handles this massive failure. See, the machine has no intuition. It doesn't know that a fox doesn't jump over a kitchen appliance. It needs a strict, unyielding mathematical way to realize exactly how badly it messed up. It needs a definitive sporing system.
To pull this off, engineers use a highly specific metric called cross-entropy loss. You can basically think of this as a mathematical formula that calculates the exact distance between the machine's super confident, totally incorrect prediction and the actual true word that should have come next. It measures the mathematical gap between refrigerator and dog. So if the machine was 99% certain the next word was going to be refrigerator, this loss function registers a massive, catastrophic error score. It's the ultimate penalty. It's this harsh numeric reprimand that tells the whole system, hey, your current configuration is completely useless.
And it's this catastrophic error score that triggers the correction phase. It initiates this relentless microscopic loop. A powerful mathematical wave, called backpropagation, washes all the way down from the top of the 12-story tower, right down to the foundation. This wave touches every single one of those 124 million knobs. It evaluates every parameter, figuring out exactly how much it contributed to that wrong guess. Then it nudges the dials connected to refrigerator slightly downward, suppressing that specific pathway, while nudging the dials connected to the correct word, dog, slightly upward. This is a massive, cascading mathematical adjustment, and it's happening across the entire network all at once.
Then, the machine takes another chunk of text and guesses again, and it misses, and it corrects, and it guesses again. It does this loop millions of times a second. It's effectively reading the entire internet, word by word, calculating the loss, updating those knobs, and trying again. Now, as you can imagine, this immense guessing process requires a sprawling warehouse of specialized computer chips, GPUs, just running at absolute maximum capacity for weeks or even months on end. We're talking tens of millions of dollars in electricity alone just to keep this computational furnace burning. But, if you let that furnace burn long enough, something really incredible starts to happen. The loss curve slowly, relentlessly drops. The machine stops guessing refrigerator, it starts guessing dog. Then it starts picking up on deeper patterns. It understands that adjectives usually come before nouns. It figures out that if a paragraph starts with a French greeting, the rest of the text had better follow French syntax.
Now pause for a second. We did not teach it the rules of the world. We just punished it until it figured them out. Really take a moment to let that sink in. There is no grammar module in there. There is no logic center. It completely internalizes the fundamental logic of human reality simply by trying to lower its error score in this relentless, purely mathematical game.
Okay, so after weeks of enduring this brutal pre-training furnace, the machine is finally ready. We turn off that backpropagation wave. Those 124 million knobs, they are permanently locked into their current positions. And just like that, you now possess a functioning artificial brain that's fully capable of basic text completion. We call this a foundation model. And honestly, the most amazing part of all this is that once this exhaustive process is done, you don't actually need millions of dollars or a massive server farm to use it. You can literally just download these open source locked-in weights and load them directly into your own Hollow Tower, right on your laptop. It's kind of the ultimate cheat code. You skip the furnace entirely and immediately get a frozen mind, perfectly tuned to the deep patterns of human language.
But as we move from this grueling training phase over to the exploration phase, there's still a really profound question we have to answer. How does this mathematical tower actually output human speech? When you prompt the fully trained machine, it doesn't just instantly and confidently spit out a single perfect word. No, the top layer of the tower first produces something profoundly alien called logits. Logits are basically the raw, unnormalized scores the neural network outputs for every single word in its massive 50,000-word vocabulary, simultaneously. Just try to imagine how overwhelming that would be for a human mind. Having to evaluate the exact mathematical viability of 50,000 different words, all in the exact same fraction of a second.
And if you look at what these raw scores actually look like, they are completely chaotic. They'd be totally unreadable to you and me. Some scores extend wildly upward into positive numbers, like an 8.4 for dog and maybe a 2.1 for fence, while others plunge deep down into negative numbers, like a negative 5.2 for a refrigerator. The machine obviously can't just hand you an 8.4 and expect that to make any sense as conversational speech. These raw, completely disjointed scores have to be forced into clean, understandable percentages before it can actually make a choice.
So to transform all that chaos into order, we pass the logits through this highly elegant mathematical filter known as the softmax function. Softmax aggressively crushes all those chaotic numbers, forcing them to sum up to exactly 100%. And this mathematical squashing is brilliant because it allows the AI to finally weigh its options fairly against one another. The machine now has this perfect probability map, giving it clear, proportional options for the next word. It might calculate a 60% chance for the word dog, a 20% chance for fence, and a tiny, almost negligible 1% fraction for refrigerator.
Right, so now that we've got our clean percentages, how do we actually pick the word? Well, the most obvious way is to use a method called greedy decoding. That's where you just program the machine to always, without exception, pick the absolute highest probability word. But there's a huge catch. If you use greedy decoding, the machine sounds completely robotic and lifeless. It totally lacks that organic, surprising flow of real human speech. And worse, because it's always taking the absolute safest mathematical path, it frequently gets trapped in these infinite looping circles. It'll write something like, the dog jumped over the fence and jumped over the fence and jumped over the fence, until its memory just crashes. Because let's face it, humans don't always say the most mathematically predictable word. We use variety. We use surprise. So if we actually want it to mimic human speech, we have to introduce controlled chaos.
To introduce this controlled chaos, we dial in a crucial parameter called temperature. You can think of temperature as taking our pristine probability map and turning it into a massive 50,000 slot roulette wheel. If dog has a 60% probability, well, it gets 60% of the physical slots on this digital wheel. Fence gets 20% of the slots, and so on. When you hit enter, you're essentially spinning this digital wheel. Now, because it holds the most slots, dog is usually going to win. But occasionally, entirely by random chance, that little white ball will land on fence. The machine will choose a slightly less predictable word, and that injects a real spark of life, giving the text a natural, human-like variety.
So here's the thing you really have to remember. The machine is not being creative. It is just executing statistics with a random number generator. That's it.
This loaded dice mechanism is exactly how the AI manages to generate new, totally unique text every single time you ask it the exact same question.
And the absolute beauty of this system is that we can control this illusion perfectly. If we turn the temperature dial way down, close to zero, we freeze the chaos. The math crystallizes, and the gap between the absolute best guess and the second best guess is massively exaggerated. The roulette wheel becomes heavily rigged toward the safest possible answer. Lowering the temperature like this produces text that is highly accurate, very factual, and incredibly boring. Which, is exactly what you want if you're writing strict legal code or trying to solve complex math equations. But what happens if we turn the temperature too high? Well, the wheel becomes completely flattened out. Every single word has an almost equal chance of winning, and the text just descends into absolute incoherent gibberish. We have to find that perfect, delicate balance.
When you look at it this way, we've essentially solved the grand mystery of artificial creativity. It is just math, hiding behind a roulette wheel. Beneath the captivating illusion of a creative, thinking mind, there's really only a hollow tower of parameters, calculating millions of probabilities and rolling loaded dice right within perfectly guarded mathematical bumpers.
When you look past the illusion of a creative mind, you realize that AI isn't an artist at all. It is just the most sophisticated slot machine humanity has ever built. But if a slot machine can write a masterpiece, what does that say about human creativity? Thank you for watching, and we will see you in the next one.